Let's factorize this one together. So we have a quadratic expression. So we have an x squared term as the highest power. So we know it's a quadratic. And just looking at this, it looks a little bit harder than the ones you might be used to because the coefficient of x squared is a 6. It's not 1. So for example, you might have seen x squared plus 8x plus 12. Alright, where the coefficient of x squared is 1, and to factorize that, you find two numbers that multiply to positive 12 and add to positive 8. So in that case, it would be 6 and 2. And so we'd have two sets of brackets, and in that we would add 6 and 2. Because when you expand it, right, opposite of factorizing is expanding, we would get 8x, and we'd also get 12. However, in this one, the coefficient of x squared is 6, so we need to tackle it a bit differently. So I'll show you two ways. So the first way is called factorizing by grouping. Factorizing by grouping. And so we need to follow a few steps for this one. So the first step is we take the coefficient of x squared and we multiply it by the constant. So in this case it is 6 multiplied by the constant, so the term with no x attached to it, which is negative 15. And 6 times negative 15 is negative 90. Now we need to find two factors, right? Two numbers that multiply to negative 90 and add to positive 13. So this sometimes is the tricky bit. So I like to just write 90, or negative 90 rather, do this little t and think of factors of negative 90. So since it's negative, we know one of the numbers has to be negative, right? Negative times a positive is a negative. But just thinking of 90, could be like 1 and 90, or 2 and 45, or 3 and 30, or 5 and 18. And so just looking at those, I think 5 and 18 might be able to get us 13, right? Because remember, one of these needs to be a negative number. So if we had minus 5 plus 18, that will give us positive 13, and minus 5 times 18 gives us minus 90. So those are our two numbers. And now what we do with those two numbers is this. So we have 6x squared, but instead of 13x, we will write that as minus 5x plus 18x. Minus 5x plus 18x. So all I did here was replace 13x with the sum of two terms, and those terms came from being a factor of minus 90, while also adding to 13. And let's not forget the minus 15. So what we've done here is we've rewritten the quadratic expression. And now, next step is zooming in on the first two and the last two terms and factorizing them separately. So looking at 6x squared minus 5x, let's look for the highest common factor. So between 6 and 5, well, there is none, it's just 1. But between x squared and minus x, it would be x. So we pull out the factor of x, and what are we left with? We're left with 6x, because x times 6x is 6x squared, and we're left with minus 5. So x times minus 5 is minus 5x. Now to 18x minus 15, we look for the highest common factor. So between 18 and minus 15, that would be 3. So we have plus 3, and then what's left over, it is 6x. So 3 times 6x is 18x, and then 3 times minus 5 is minus 15. And now you might have noticed between this term and that term, they both have 6x minus 5. So we can actually factorize it again. So pulling out the common factor of 6x minus 5, this times what gives us x times 6x minus 5? Well, that would be x. And then this times what gives us 3 times 6x minus 5? Positive 3. So again, just on that step, we could check, we could expand it out. So this times x gives us that term. This times positive 3 gives us that term. And we have factorized it, right? We have our two sets of brackets and our expression in terms of x. So that's factorizing by grouping. You should definitely try some more problems on that. Khan Academy has a great resource on that. The other way we could solve this problem is using our calculator. Now, I only recommend doing this if you're stuck or you want to check your answer. So to do this on our calculator, we actually just assume this equals 0, and then we solve for x, right? We find the roots, which will let us sort of reverse engineer the factorized form. So we go menu, we go to equa for equation, we hit F2 for polynomial, because this is a quadratic, it's a polynomial. It's degree 2, because that is a quadratic. And a, b, and c are these values here. The coefficient of x squared is a, coefficient of x is b, and the constant is c. So in this case, a would be 6, execute, b would be positive 13, and c would be negative 15. Right, and then we just hit F1, which is solve. Now this says that the solution, right, the roots are x equals 5 over 6 or negative 3. Cool. Now, great. Now let's reverse engineer the factorized form. So we'd have our brackets. Let's keep it as an equation though for now. And we would have x, instead of plus 5 over 6, we'd actually have the opposite sign. Instead of minus 3, we'd have plus 3. And this is because when we solve this, we set this whole bracket equal to 0. And if we solve that for x, we would then get the positive 5 over 6. Similarly, if x plus 3 equaled 0, x would then equal negative 3. Right, so we're working backwards. So how are these two different? The x plus 3 is the same, but notice that first bracket is 6x minus 5, which we can get to by multiplying both sides by 6, leaving us with 6x minus 5, x plus 3, still equals 0. And I guess this is the drawback for using our calculator, as opposed to factorizing by grouping, because we could just times it by whatever we want when it's an equation. Yeah, so again, use your calculator to check or to help if you're unsure, but do learn factorizing by grouping.